Ciao friends! In this Unplugged video, I want to talk about circular dependencies when you create relationships based on calculated columns or calculated tables. We will use the calculated column, but the principle is the same. We have to pay attention to the Redux code we use because if we don't understand how the presence of a many-to-one relationship could affect the dependency, the circular dependency, when we use particular DAX functions, we might be in trouble. We might not be able to create the relationship, or after we create the relationship, we might not be able to modify the DAX code that we wrote. So we will see a number of examples, and we will see a few pointers to articles that explain the expanded table and the blank row, which are important concepts to understand why we might encounter this trouble. So let's start with the demo. So the starting point is a model we use in a DAX pattern that is called static segmentation. So if you want to know more about the pattern, I give a pointer to this article, but we want to focus on one problem, which is the presence of a relationship in the model based on a calculated column. So let's take a look at the model we have. And the model we have is a classic contoso where we have the table sales, the table customer, the table product, the table date. So these are the classic tables for a contoso database. The goal of this model is to create a segmentation of the transactions based on the price of the transaction. And depending on the price, we want to group all the transactions in a certain range depending on the customization we have in the price ranges table. So the price ranges table is a table we created in advance where we have these 5 names. So the goal is to show these 5 ranges in the report and group in each range all the transactions where the price is between 0 and 10, 10 and 30, and so on. Of course, we have to exclude the max price from each range, because otherwise 10 will be present in 2 ranges. We don't want this to happen. And the presence of this table is something that suggests us that we want to create a relationship between sales and price ranges. However, in order to create this relationship, we need a column on the many side, the sales table, where we have the same value of the price range key. So the price range key is a number, 1, 2, 3, 4, 5, and we want to use this number to display, not to display, but to retrieve the corresponding range for a particular price. For example, let's say that we have in the sales table, we have a net price of $9.99. So all the rows that have $9.99 should be connected to the price range number 1, price range key 1, which is very low. So we want to display very low, but in order to display the price range column of this table, we need to create a relationship with the sales table. So our goal is to create a price range key in the sales table and then connect the sales table to the price ranges table with the same with a column with the same name. We will discover that depending on the DAX technique we use, we might encounter circular dependencies problem. And the goal is just to understand all the problems that we might encounter and also understand which strategy we should use when we create a calculated column that could be used in a relationship. So let's start with the calculated column we want to create in the sales table. And in order to create the calculated column, I can actually use different strategies. I will show different techniques, and then I will comment most of these techniques, because one by one we will see which kind of problem each technique can create. So let's start with the price range key column that can be written by using a function that, based on the current value of the net price in the current row, retrieves the corresponding value of price range key. Because it's a range, we have to create a sort of filter. So let's say that we want to create a filter where we filter the price ranges table, and for each row we want to check whether the price ranges table min price has to be less than or equal to the net price, which is the column net price in the sales table. So by writing a filter, I'm iterating price ranges. I already have a current row in sales, so I can actually use two column references in the same predicate. And of course, I also need a condition like max price should be greater than sales net price. Sales net price. So by doing this, I will get a table that has, in theory, just one row in as many columns as the price ranges table. Indeed, if I click enter, I get an error because my expression refers to multiple columns. In reality, I just need one column, the price range key, so why not using select columns? If I use select columns, and out of this table, I get just the price range key column. So select columns will extract only one column. I have supposedly only one row, and if I did my calculation correctly, now I have my price range key, which now is 1 when the net price is $9.99. If I scroll down, I have different values depending on the net price. So far so good. Remember, this is the first technique I used, and I could have used many other techniques. For example, let's comment this one, and let's see which other techniques I could have used. Because at the moment I use the select columns filter, but what about a calculate statement which filters the column min price and max price? So for example, I could have wrote a calculate where I want to use the same filter. So I could use the same filter as a table filter in the filter context, but in the first argument of calculate, I want to retrieve the values of price ranges, price range key. So this could be another technique. And if I try this technique so far, I think it should work. So let's try. And as you see, yes, it works. So the value is still 1. If I scroll down, I see the other values. It just works. So now we have two versions of the same calculation. So let's copy this code down here. And let's create a variation of this code, because I might say, well, I don't like a table filter in calculate. I prefer to use column filters. So why I don't use something like this? So why I don't use just one column filter for min range and one column filter for min price and one for max price? I could do that, but at this point, I cannot create a predicate by using two column references. I have to use only one. However, it's easy. I can just store in a variable current price the value of sales net price, so that I can return the value of calculate with the two condition using current price. And once again, I click enter. I check the result, it's still 1. And if I scroll down, I see other values here. Let's see. Yes, it just works. So far so good. It seems that I have 3 different techniques to create my calculated column price range key. And let's start with the first one. So I want to comment the 2 new techniques I used with calculate, and I want to use the original one with select columns filter. Okay, so let's start with this one. I will explain you why later. And now that I have this column, I can go back to my diagram view, and I can connect my price range key column in sales to the price range key column in price ranges. By doing that, let's try. Actually, the creation of the relationship worked, and if I go back to my report, I can use the price range name in the report, and I can use this to filter, to group the transaction of the sales table by price range. Of course, now price range is sorted alphabetically. I would like to see the price range name sorted by price range key, so I can just use the sort by column in the price ranges table, and I have very low, low, medium, high, very high. So far, so good. Now, first of all, my interest is to dig into the potential issues of the circular dependencies, depending on the calculation we use. But before doing that, let's think about this. I just used filter price ranges without worrying about checking whether there were more than one range active at the same time. What does happen if I have a configuration in price ranges? Imagine price ranges could be an Excel file we import in our model, and it could contain overlapping ranges. If this happens, we might have multiple rows in price ranges that are valid. At that point, this calculated column will fail. For example, let's go to the price ranges table, and let's edit this table. So if I go here and I modify the code, for example, I could write here, let's say 200. So now, if you think for a moment, any value between 30 and 150 belongs to two or more, actually between 80 and 150, 200, belongs to more than one price range. If I click OK and I go back to this diagram view, what happens at this point, there are changes applied. The changes are applied. If we go back to sales, you see that now my calculation is producing an error. I don't see which error, but if I click on the column, the error message we have here says a table of multiple values was supplied where a single value was expected. This is the kind of error we expect in this case, and one thing we might have done is, for example, we could intercept this error to raise a different error message, just because we know that if there is an error here, probably there is a wrong configuration in price ranges. So we could write something like if error. So if this code generates an error, we can assume that there is something wrong in the price ranges table. Check the values. So what I'm going to do is I'm going to show you a technique to customize the error that you see in case of an error. So if error intercepts the error, and in case of an error, instead of returning a different and valid value, I just return an error. So I raise a different error, but this way I can control the message. Remember, this message is written in if you refresh the model in Power BI service, this message is written to the administrator. So it's sent to the administrator, is written in the log of the execution of the refresh. So it's a way to transform a generic message into something more specific. So this is just a useful technique that I often show to students during courses, because it's a common request. How can we customize, or how can we intercept and control the errors? Now let's go back to this case. So we said, okay, if we have more rows, we have an error. So we have to make sure we don't have a configuration error. So now I restore a correct configuration for my table price ranges. So I go back here and I restore this number to 80. I click OK and I close and apply. So as you see, this technique just works. So by using the functions I use now, I don't have any problem. I created my relationship, everything is working. But what happens if I use one of the other two techniques that we have seen before? Let's start with the first one. So let's comment the select columns technique, and let's use the second technique we used here. So now I use calculate, values, price range key, filter, and I filter the price ranges table. We saw before that the result is the same. This is just another technique. But if I confirm this technique, if I confirm this formula, now I have a circular dependency. Wait a minute, this code was working before. It was working when we didn't have the relationship active in the model. Indeed, if now I remove the relationship, I delete the relationship, and I go back to sales price range key, and I confirm this code, now the code has been executed. My column price range key is correctly evaluated. But of course, at this point, I don't have the relationship. And if I try to create the relationship now, so now the column exists, but the relationship generates a circular dependency at this point. Why do we have a circular dependency? So this is one of those cases where we have to understand that the presence of a possible blank row in a one-to-many relationship is what is causing this circular dependency. So in order to understand this, let me just restore a valid select columns. So I get the second one. I want to create a relationship because it's easier to explain what is going on if I restore the relationship. So with this code, it works. Now I try to replace the code with the calculate statement that uses values and filter. At this point, I have the circular dependency. Here we go, circular dependency. What is happening? So when you see the circular dependency in a calculate column involved or in a calculate table involved in a relationship, you have to figure out whether you have, in the code we have now, this code, do we have some function that depends on what we have on the one side of the relationship? In particular, do we have something that depends on the presence of a blank row? Let's try to figure out. So remember, we are evaluating the price range key in the sales table. And if we have a function that could return a blank row on the one side of the relationship, because remember, now we have a one-to-many relationship active in the model, well, in order to know whether a blank row exists, this function asks to price ranges, do you have a blank row? And price ranges says, wait a minute, I check. In order to understand whether there is a blank row or not, an additional blank row or not in the price ranges table, the price ranges table must check whether the values that exist on the many side of the relationship, so the many side is sales, in the price range key column of the sales table, is there at least one value that doesn't exist in the price range key column of the price ranges table? Imagine when you have 10 products, 1 to 10, and you have in sales a product which has ID 12. Well, ID 12 doesn't exist in product, so there will be an additional blank row in product to group all those values on the many side that don't match any of the existing values on the one side. So remember, we started from price range key. Price range key says, is there a blank row? Because we have a function that could include the blank row. Price range says, wait a minute, I check, and it asks for the values of price range key, which is my column that is evaluated, and my column says, wait a minute, I ask. And this creates the circular dependency because the price range key asks to price ranges, which asks to sales price range key, and this is the loop that creates the circular dependency. How do we break this loop? We need to avoid on the many side of this relationship to have an expression that depends on the values that we have on the one side, because this is what creates the circular dependency. So if we take a look at what is a function that depends on what we have on the one side of the relationship, well, in this case, it's easy. It's values. Values is a function that includes an additional blank row, whereas distinct is the function that ignores that blank row. So by using distinct, the expression we wrote no longer depends on what we have on the one side of the relationship. So the fact that there is a valid or invalid relationship that displays or not the blank row doesn't matter anymore. By the way, these concepts are explained. So let me check here. We have in the blank row index, this article has a number of information that describe the presence of the blank row in the functions like all, like values, and describe in more details how this concept works. So the first takeaway, when we create an expression in a calculated table or in a calculated column that could be involved on the many side of our relationship, pay attention to not have functions that could depend on what we have on the one side of the relationship, because we want to avoid the dependency on the blank row. Now, this is actually code that still has some issue, but for a reason that I will explain later, there is something that is hiding the issue now. In order to explain you what the real problem could be, let me use the third version. So the third version here is the version that we also tried before, and this version also generates a circular dependency. Now, we know that we don't have to use values, so let's use distinct. But now, you see that we have a different way to describe the filter. Instead of using a table filter over the entire table price ranges, we are including a column filter for min price, price ranges min price, and another column filter for price ranges max price. Remember, now we have the relationship active in the model. I try to confirm this code again. And once again, now my circular dependency is back. In order to understand what is going on, now we have to go deeper in how DAX works and also in what happens when we have a many-to-one relationship. Let's start with the first element, which is there is a function now hidden. We don't see this function, but there is a function that depends on the presence of something on the one side. In order to understand which function is, we have to expand the predicate we have in calculate, just the regular column filter, into the complete syntax, which is a filter, which is a function that filters all the values of the column. So whenever we have a predicate in calculate, in reality what is happening, we have a table function that filters all the values of the column we want to filter, applying the predicate. And the same happens for the second one. So max price, and this is what we have. Now, this is the same code I wrote before. There is no differences. There are no differences. I just wrote in an expanded way what we had before in a shortened version. But now, this code makes it visible the presence of another function that, like values, depends on the presence of the blank row on the one side, and this function is all. By using this expanded version, we can see this dependency, and the reason why we have this circular dependency is the presence of all, which could include a blank row, which actually we don't need. So we can just ignore that blank row by using all no blank row. So if we want to use this syntax, we can, but we just have to write in an explicit way the table function that actually does not depend on the presence of the blank row on the price ranges table. Now, this code actually solved one problem, but if I click enter, I still have the same circular dependency error. And why is this happening? Well, this is more complex. But in reality, you have to remember what happens when you have calculate and you have an active row context. We have a context transition. And when we have a context transition, the current row of the current table is sales, so we have a current row in sales. The current row becomes part of the filter context. However, when a table has many-to-one relationships like sales, the table that is applied to the filter context is the expanded table. And the expanded table includes all the columns of all the tables that can be reached following many-to-one relationships from the table that you specify, which means that the expanded table sales includes all the columns of sales, all the columns of customer, all the columns of product, all the columns of date, and of course, yes, all the columns of price ranges. So the fact that we have a context transition means that we have all the columns of price ranges that could be blank. Yeah, because we could have a row in sales that has a value in price range key that doesn't exist in price ranges. Of course, the goal of our code is to actually retrieve an existing value, but the engine doesn't know that, and the dependency is what is triggered by the presence of this filter. And how can we avoid this? Well, we simply remove the filter. So we have many ways to do that. But first of all, if I just remove any filter, by writing remove filters, I'm saying remove any filter. I'm in a calculate column. I don't need the context transition. I can ignore the effects of the context transition. I can write remove filters. I could have wrote a remove filter sales, but actually, if I don't need any effect of the context transition and I don't need any filter at all coming from outside of my calculate, I can just remove all the filters. And by using remove filters, this just works. I could have used remove filter sales, same thing. To be honest, I could have used remove filter price ranges, and this would work the same, because the dependency is only the filter applied to the price ranges column. So the idea is that by removing the filter from all the columns of a table, we also remove the circular dependency, because at this point there is nothing that could have a dependency on the blank row we have in price ranges. The reason I wanted to write the code with the remove filter price ranges is because in reality, this code explains why this code at the beginning worked. So let's copy this code here. So this is the code that we wrote now. So let me comment it. And let's restore this code. If you remember, when we renamed values to distinct, it worked. But it worked without worrying about the context transition. Why? Because the context transition generated by calculate was overwritten by the filter price ranges. Because price ranges includes all the columns of price ranges and the price ranges as a table reference ignores the blank values. Indeed, when you write price ranges, you are not including the blank row. Otherwise, you have to use values. These values will include the blank row, and this will create the circular dependency. You see that now we have the circular dependency because we used values. But when you use just the name of the table, then this table overrides the column price ranges, removing the circular dependency. What is the take? Oh, before we move forward. So the concept of the expanded table is explained in this article, Expanded Tables in DAX, and of course in the definitive guide to DAX, where you can see more details about how the expanded table is defined and works. But behind the cover, this is the concept that we have to understand in order to control what happens. So, takeaways. If you remember, the first code I used was this select column. So let me restore this. I didn't use calculate, no context transition. I just used filter over table, and I used select columns to retrieve only the column that I needed. If I had multiple rows, I would have had an error, and I could intercept and change the error. But basically, even though this code could be not the more efficient one, because calculate is usually better, but remember, we just have a small table, just a few rows. We have a calculate column executed only when we refresh the data set, the semantic model. So why not? This code is simpler, doesn't generate many head caches, and we don't have to worry about the dependencies because we are not using functions that could depend on the presence of the blank row on the one side. Of course, sometimes we have to use calculate, and so when we use calculate, to be honest, I don't know if I want to write this code. Because this code, this code is potentially faster, but actually is way more complex to write because we have to translate every single column predicate into a complete filter just because we want to use all the blank row instead of all. So you see that at the end of the day, it's not a bad idea to use a simpler expression. The select columns is one, but also the calculate with distinct and filter could be not so bad. At the end of the day, though, if you want to just get rid of the context transition, and maybe you have more complex filters that you don't want to simplify too much in a table, remember, remove filters without any argument or just with sales, get rid of any filter coming from the context transition and removes the need for looking around at many other details, because understanding the circular dependency that is generated by the context transition sometimes is all but easy. So it's actually something we don't need. So if you create calculate without needing the context transition, just remove the filter as soon as you can, because this will make it easier to control the code. So we have seen that by using calculate, by using all, by using values, we might encounter problems in circular dependencies when we use relationships based on calculate columns or calculate tables. The takeaway, keep it simple, try to avoid functions that could create these dependencies, and if you want to stay away from the problem, of course, use the simpler code that you can in DAX. If you cannot avoid that, then pay attention to how the expanded table works, because the expanded table is responsible for the effect of the context transition when you have a many-to-one relationship. And remember, keep in mind which functions depend on the presence of the blank row on the one side of the relationship. All and values, instead of those functions, you can use all the blank row and distinct. Enjoy DAX!